Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll sketch a graph of a function based on the concepts of derivatives. So as per the problem, sketch a graph of the function g that is differentiable on the interval -2 to 5, decreases on the interval 0 to 3, and increases elsewhere on the domain. Now the absolute maximum of g is 7 and the absolute minimum is -3. The graph of g has local extrema at 0, 4 and 3, -1. So the first thing we should analyze here is the interval on which the function is differentiable. So that means in that interval from -2 to 5, there is no vertical asymptote, no jump in the graph, or no cusp point. So this interval becomes the domain for this function. So that means the graph that we sketch should be between x equals -2 and x equals 5, including the endpoints. We shouldn't graph beyond this domain. Now next we are given the interval on which this function is decreasing. And that is 0 to 3. So we can use this given decreasing interval and domain to find the intervals on which the function is increasing. So as per the problem, so the function is increasing elsewhere on the domain. Now the domain starts at -2 and the decreasing interval starts at 0. So that means this function is increasing from -2 to 0. So that's the first interval over which the function is increasing. Now the next interval on which the function is increasing is from 3 to 5, because the decreasing interval stops at 3 but the domain stops at 5. So these are the two intervals over which the function is increasing. Now we are also given the local extrema, which are at 0, 4 and 3, -1. So next we can plot these 2 points because these 2 points lie on the function. So the first one is 0, 4, which is the y-intercept, and the next one is 3, -1, which will be here. Now we can start sketching this function. Now the domain starts at -2. So first we'll analyze the increasing interval -2 to 0. So on this interval, the graph should be sloping upwards from left to right because any tangent we draw on this graph should have a positive slope. So that means on this part of the graph, we have to go from a lower level to a higher level up to the point 0, 4, because first we are graphing on the interval -2 to 0. Now since we are given that the absolute minimum is -3, so and we are sloping the graph upwards in this interval from -2 to 0, so we can show the absolute minimum -3 as the starting point for this part of the graph. So our starting point will be -2, -3. And now we can show our graph as a curve that starts at x equals -2 and goes all the way up to x equals 0. So this can be our first part of the sketch. Now we can analyze the next interval. Now to the right side of x equals 0 is the interval 0 to 3 over which the function is decreasing. So that means this local extrema 0, 4 represents a local maximum. And on the right side of x equals 0, the graph should be sloping downward because any tangent to that graph should have a negative slope. So that means our next local extrema 3, negative 1 will be a local minimum. So now we can draw the curve between x equals 0 and x equals 3. So we can show it like this. Now, as per the analysis, so the next interval is 3 to 5, and over this interval, the function is increasing. That means we have to show the graph going upward from left to right because any tangent to this graph should have a positive slope. Now, since this part of the graph is going upwards from left to right, we can show the absolute maximum point on this part of the graph. And since the domain ends at 5, so the end point for this graph will be at 5, 7, and that will be this point. So now we can join the point to the local minimum. So this should be the sketch of function g. So these are the steps you have to keep in mind to solve a problem like this one. So you have to be very careful in terms of how to show the given absolute maximum and absolute minimum points. And we use the increasing and the decreasing intervals to identify how we can or where we can show the absolute maximum and minimum points. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.